There you go. Right, well, welcome to Datashield, everybody. Glad you could make it, and happy to see so many of you interested in learning about Datashield as a newcomer. We designed this presentation and this script to tailor it more to the very beginner end than some of our previous workshops, which you may have come across on YouTube. So we're really just going to do simple functions, look at syntax, look at arguments, why things are sometimes breaking. And then if you want to look at more complicated things, there will be future such workshops and also forums, etc. for that. So firstly, I know Dimitri told me that a few of you joined at the last minute, so we haven't got your details in our spreadsheet. So if you wouldn't mind, could you put your name and institution in the chat? Elaine, am I missing anything important there?
No, yeah, if that would be great. Yeah.
Thank you.
Name, institution, and also the project that they're working on, that would be helpful.
Cool. So I shall continue. So I've kept this slide really simple to explain what is Datashield. So first of all, it's a packages in R. So you need to know the R statistical language to get started, or it certainly helps. We are an open source project. So that means you can view all of our code online. It's not behind any, it's not paywalled or anything like that. And so at any point you can go into our GitHub and see exactly how a function is working and learn more about the internal structure. Also, we have built custom functions. So this isn't just using existing R functions like mean or anything like that. We've actually re-engineered these functions so that things pass to a server where the data is stored and does the calculations at that end, and then passes back only things that we have calculated that are definitely non-disclosive. So that's done for you, and so it can be relied upon to be privacy preserving. You'll see in a second, I've got an animated slide of how these things move about and what things happen where. And its main usage is for analysis of individual level data. So that's its USP, if you like. So moving to the animated slide. So picture of the world with various servers distributed across it. So a few in Europe and one in America. So that's me in the UK. And looking inside that, we have got the analysis session. So that's me. And the server session, so that's on a remote computer, is actually physically elsewhere. So you are given login details from whoever is allowing you to study this data. And these get sent through the internet. So once they have been verified, you are allowed into the R environment. And this establishes the connection between your computer and the data server's computer, which we will be calling a Datashield session. Then you write your code. Maybe you want to know the mean of a particular variable, and maybe its variance, covariance with another variable. And once you're happy with that, you you hit enter, but that actually sends it through the internet and it lands at the server where the data is stored. It then is applied to that data and results generated. So you can see that's happening remote from you. You can't interfere with that. And you also can't customize the results to discover anything that you're not supposed to. Only the results come back through to you. And you can interpret them, but they absolutely shouldn't be revealing of individual level data in any way. So that happens simultaneously from all of the other servers as well, because your script will be sent to all of them as well. And then, so the meta-analysis, that pulls together all of the different servers' results that have been sent back to your computer and presents them in a way where you can see individual server answers, but also the collective answer across the servers. So this is really important if you're doing a cross-sectional study on lots of data around the world, but that data can't be moved physically to the same location. So today, to actually get some practice at this, we are going to analyze some Titanic passenger data that I found on Kaggle, or Dimitri actually found. Thank you, Dimitri. So I thought this was pretty good because we're all fairly familiar with Titanic, and the passengers are, well, it was a long time ago, so it's not actually a disclosure issue. But because it's individual personal data, it's the right kind of scenario for that, for the Datashield analysis. So if Titanic in 2021 had passenger data, then those are real living people. We do have to respect their confidentiality and say that they had bought those tickets from 2 different ticket offices, and then the logs of those purchases were stored there, then we would connect to each ticket office's server and analyze the data there and bring the results back to us. So this is a good place, a good situation for Datashield to solve a problem. And now we're going to watch me tab across to our studio and do some code. I'll make this a bit bigger. Can you let me know when it's big enough? I'm hoping that's good.
Yeah, that looks fine.
Okay, so just a bit of preparation here. I'm not using a regular R script, in case that's what you're familiar with using R. This is an R Markdown script, which is pretty similar, but instead it has this section here written in Markdown. So that's very useful for publishing it on the web later. And then these chunks of code here. So what you can do is hit this green button here and it runs the chunk of code only. It doesn't run all of the document's code. So yeah, it's pretty simple to use, and hopefully you'll be able to use it fine. I am going to be providing this R Markdown script to you at the end of the session for you to have a go at the commands yourself. So I, of course, have already installed these packages, but I have left this in case you have never done this before. So because Datashield is a collection of packages, you need them on your computer for the client-side functions to actually run properly. So I'm not going to run that now because it might clog up my computer for a minute or two. But I am going to click this button to run these lines here to make sure all the functions are loaded in using the library command. So you can hide the output of what you've just created here. So what we're going to do today, I have simulated the data on servers by putting it onto the Opal servers that our colleague Yannick Marcon runs in France. So this is a server running every day with lots and lots of different test data sets on, but also today it has the Titanic data set on. Oops. So the first thing you want to do, that connection stage that I showed you in the animated diagram, that is achieved by, first of all, building a login data frame. So that's a data frame containing all the key pieces of information you need to get onto the server and validate that you are a user on that server. So let's have a look at it. First, you use the new DS login builder function. So usually you don't have to remember all of this. This is in a lot of places online, such as our wiki. You can just usually copy and paste this whole chunk and then go in and customize the individual arguments with whatever you've been given for your particular study. In this case, we will start with the URL. This is the server's URL. So it's secure HTTP connection. So I've pasted that in here. I've been given a username, DS user, and the password is password. Obviously, being a demo, it's not terribly important, but hopefully the password you get given for the real life data is a bit more secure than that. And then that's got us onto the server itself. But what actual data are we going to analyze? Well, it's stored in a folder and then a table within that folder, and it's separated by this dot. So there's another one on there called CNSIM, and CNSIM has the tables named CNSIM1 and CNSIM2. So in that case, you would put CNSIM here and CNSIM1 here. So the project and the table. You can just leave this be, that's always there in the login data frame. And this argument here, the server equals, that is for your benefit. So that's what is going to label results coming back from the server at the client side. So for clarity here, I've just renamed it what I know the table on the server already is. So I've just gone with Titanic server 1 and Titanic server 2. So, and this line here, this actually compiles the data frame you just created and assigns it to a local object. That's green bars showed it's all gone well, no error messages. And then this line here is important because this is the datashield.login function. So that takes the login data you just created up here, and it tells the server what you're going to be calling the data frame where the data is stored. You can actually customize this to be A or B or table, whatever you like, but we're going to go with D because that's pretty standard across Datashield. And then it assigns it for the purpose of future functions to a local object called connections. So we run that, and we should see popped up here is progress bars, it actually just appeared instantly because Yannick's server in France is really quick. And we didn't do any specifications in the login data frame, so all the variables in that table have been added to our session to get studying them. If there's a problem with what you've written in your login, then you would expect to see an error here. So we're going to try that so you can be prepared for what an error looks like and how to bug fix that error. So I'm going to run this that has an error in it on purpose. So obviously a lot more text going on here. So here it says failed, no data source exists with the specified name. So what we have to go back up and do here is identify which part of this has gone wrong. So here I've accidentally written June 2020 when it's actually June 2021 is the correct name. So by correcting that and then hitting run again, oh, this actually has the wrong table name as well. So I'll copy that. So what it's actually saying here is this project is not accessible. Well, it's saying the table is not accessible, but that's because this bit here is incorrect. So what we need to do is replace the actual project name with the correct project name, which is just Titanic. And then we hit run. And that is looking good. No problems being highlighted in any error messages. So good. Let's continue. So now that we're on, that connection that I showed in the animated slide is made. We want to actually explore the data. So what are some standard questions you might want to ask? What size is it? What's the metadata? What do we actually know about it to start studying it? Well, say we want to know what size it is. We want to know how many rows and how many columns. There is the dimension function. So quickly I'll note here, dsdim is our notation for the dimension function. So dim is a pretty standard base R function, but to show that it's part of the Datashield package, we've got this ds for Datashield and then dot. So if you ever see that, that's a good sign that it's part of Datashield. And this is often, the suffix part is often the same as in base R, but you do have to be careful and check the list of functions available to make sure that you're not just assuming it is. It might have got a slightly different name. So here, of course, as in base R, you can put a question mark before the function to bring up the help. And every single function in Datashield has a help document with it. And it will give you standard arguments. So you can see which arguments, if you're not writing them, are defaulting. And then a bit more detail about what goes in those arguments and details about its actual use. And in many cases now, we have actual code that you can paste into your RStudio session and try it out for yourself. Here there looks to be two different helps examples to help you. So let's use our first Datashield function. So here in our notebook, I'm just going to highlight one line of the R area and press Control and Enter, because that runs just that line, not the other ones. So this part here is showing that it's being sent over to the server. Calculation is being made, and then it is being sent back, and it's done it in just 1 second. And we're seeing that on server 1 there are 11 columns and 444 rows, and on server 2 it's 11 columns and 447 rows, so slightly more data on server 2. When I uploaded it, I couldn't quite make it even. And then this is quite important. The the aggregate of the result actually combines the two servers if you're interested in the study overall. So this actually has 891 rows of data for us to study if we're just interested in the bigger picture. But Silver, it's all very well knowing what columns there are, but not if we don't know what they contain. So this col names, short for column names, is the tool for the job. So I'll bring up the help again. So yeah, there you go, quick description of what it actually does. And then we actually run on our data. So here we need to, the first argument is addressing D, that thing that we specified up in the building and login data frame section. So because this is being sent over the internet to France and then being processed by the server, it actually needs to be put inside quotation marks like I've done here. As far as I know, single quotation marks always work. Single quotation marks also work, but Dimitri would have to correct me if that's not always the case. So X equals here, what does X equal? That's actually the input data frame. So it's what we want to address col names to. So we're addressing it to D, the entire data frame on the server. And then the second argument here is data sources. And data sources is that thing that we specified here when we actually did the datashield.login command. So that tells the function exactly which part of the server you want to connect to. But here we're just connecting to everything. So I'll run it. And we have a printout of the result. So this has done a few more stages than last time. And then we get the column names of server 1 and of server 2. So all 11 in each case are the same. But even then, that's not perhaps ideal. We need to know what sib_sp means. I don't know what that means. So we need some metadata about this. Well, we can access this on the Opal server portal, which you can access via your web browser. So, right, I'm going to go across to my browser, so Chrome in my case, but any browser. And then I'm going to use those credentials in the script, ds user and password. And so we're on the dashboard. And we want to get into the Titanic data. So we click on projects here in the top left on the bar, and then we see Titanic here. So we click on that, and that gets into the Titanic project. And then on this left-hand panel here, there's this icon for table. And then we can choose either of the data sets to have a look in. So here we can see the name as we just got from column names on this column here. And then the actual label, which is an interpretation of what it actually means. So that's, you can find out from this that SIB-SP actually means the number of siblings and spouses on board Titanic for each passenger that has a recording of that. So back to our session. Now that we've run a couple of functions, let's just remember what you can't do. So this whole infrastructure is so that you can't actually directly view the data. That's the whole point. So while that might be a culture shock, it's certainly when I joined Datashield, I was very used to just using the head command, for example, to look at the first few rows of a data frame and gather the gist of what it's all about. You can't do that. You have to find roundabout ways of doing that, if of course it's actually allowed and doesn't break some disclosure issue that I hadn't thought about. So what is it possible to do in Datashield, since every function is custom built and there's a finite number of them? So on our wiki, which anyone can access via the Datashield website, datashield.org, I'm going to go to this link. It's this one. And there's all of the current functions classified into their broad categories. So data preparation, administrative functions, data analysis functions. So there you'll see familiar things like the mean, the variance, correlation, quantiles, tables, distribution functions, and even modeling functions. So this is a really useful resource if you're a new beginner and you want to look at what is available. So I'm going to put that into the chat. There you go. So I've gone through that list ahead of this workshop and chosen the functions that I want to show to you. But any that I don't show to you today, just copy the function and put it into your console and just do a question mark ahead of it, and you'll get the help how to use it. And of course, feel free to ask on our forums or our drop-in sessions if you're not getting how to use it and you're getting stuck. There's a built-in Datashield command to do the same thing, but of course it's not in any sort of classifications, but maybe that's all you need. So yeah, it's printed out all of these here. Seems to be 101. So I'll hide that output. So now that we've gone through the introductory bits, shall I just pause and open any questions? I'll give you a minute to type anything into chat. I'll just have a drink. Sergio, were you wanting to ask a question?
Yes, thank you. I just to be sure, so you need to set up also the server where are you querying need to be set up for Datashield, and so you have a is a Datashield server that you're using.
So,
correct. Oops, sorry.
That's okay. So no, Datashield is the infrastructure that you will have deployed on your computer, but also the server who is providing the data to you will have set up on their computer. So once they've set it up and they've tidied the data, uploaded it to their servers, then they will provide you the login information. You will log into it and then use the Datashield commands to analyze it non-disclosively, if that makes sense.
Okay, so it's only a matter of server, let's say, architecture. So how you put the folder and project and so on. So there is nothing Datashield in the server.
Well, the server we have, there are actually two implementations, Opal and Armadillo. They are the server which you would need in the infrastructure to deploy the functions. And what happens is Datashield is added to those servers, and each has its own mechanisms for then associating that server with data which you can access via the Datashield libraries.
Okay.
Those packages you can deploy using, for example, Ubuntu Package Manager, or we actually have Dockerized deployment images ready for people to use to deploy the system.
Okay, perfect. So there is some effort on the server side, let's say the data source thing.
Yes, but as you'll see here in Alex's presentation, there are a few existing servers which are publicly available for people to get some hands-on experience with the system before deploying it themselves.
Okay, great. Thank you very much.
All right, if there's nothing else, then I can continue on. Ooh, that is deleted. Right, okay, so continuing on. So we know a bit more about the syntax and the arguments of general Datashield functions. So now it's time to actually start looking at what different ones there are and the intricacies of trying to use them. So, for example, if this data set hasn't been tidied, there might be missing values. So the function to find them, or find how many there are, is this ds.numNA, so number of NAs. As ever, I've included the help function here. That's for later if you want to download this script yourself, which I've uploaded to Google Drive. Then you can run this at any point to get some more information. But I'm going to run this line here. Oh, I'll quickly point out. So we're not just addressing the entire data frame D anymore here. We're actually looking at the age column of our data frames on the server. So the result of this is that there are 87 missing values on the first server and 90 missing values on the second server. So how many non-missing values are there of age? Well, we can't directly ask that, but we can work it out by deducing from the length and the difference. So ds.length is the length of a vector object in the server. So we'll run that and we'll get the answers 444, 447. So that's actually a similar answer to DSDIM, but just the length, not both dimensions. And then taking those answers, we can run the difference, taking those numbers, yeah, and print out the results. So actually the same, that's I would have thought it'd be different, but maybe it is just by random chance the same. So there's another function which does something a bit different, even though it doesn't look like it. It's this complete cases function. This function, if you look at the help, it looks at the entire data frame and strips out any row where any value is missing. So we're going to run that and see what happens. So we have been assured that the object is created and that it is valid. So valid in all sources, and data object has been created with this name. But we're not seeing it. So if you think about it, well, if it printed out what it's created, that would be printing out an actual data frame, which is containing actual individual results, and that goes against the ethos of Datashield. So instead, it's just saved it to the server and left it there for us to do other non-disclosive analysis to it without bringing it back to us. And in Datashield, we call this the assign type functions, the ones where it does something, it saves it to the server, but you're not allowed to see it. So what are its properties, this new object that was created, D_complete cases? Well, we started with DSDIM for the whole server, so why not do that again? So here I'm going to run this, but it's going to throw an error. And what we've done wrong here is assumed that it's created a new object as additional column or columns of the existing data frame. Well, that's not correct. When it creates a new object, Dimitri, is this the case in most assign type operations or all assign type operations?
It's the case for all the assign operations.
Okay, thanks. So it's not actually going to create it as a vector of an existing data frame. You actually have to address it as a completely different object. So I'm actually going to write a new line here, ds.ls. So now here we see on server 1 and server 2, not only do we have D like we had before, but we have this new object D_complete cases. So that's what we have to address using this x equals argument here. So if I run that, so that's the actual result that we were hoping for originally. It's 11 columns as before, but only 87 of 444 rows have survived the purging of any row where there was a missing piece of data. So that wouldn't actually be too good to do on our data set, or if we wanted to do subsequent operations on that, we might have to ask the data manager to tidy their data set a bit. Oh, and to quickly point out, this DSDIM, that has returned some numbers to us, some statistics about the data. So because it's come back to us, we refer to it in Datashield parlance as an aggregate type function. So that's really important to remember, to always differentiate between aggregate type functions and assign type functions, and not to expect numbers to be printed on our user side if it is an assign type function. So what about discrete data? Well, firstly, we need to work out if it is discrete, since we can't actually look at it. And so we can use ds.class, which is very similar to base.r class, to work this out. We're going to look inside data frame D and look at the embarked column. Running that. Good, so it is a factor. So if you want to tabulate discrete data, it needs to be a factor, else it doesn't run the function correctly. So now that we know we want to use a table to tabulate discrete data, how do we actually use that? Well, we will use the help function. So ds_table has quite a lot of arguments, but the key one we want to use in the first place is just this first rvar. So I'm going to demonstrate here. If we just assumed it was ds.table x equals d.embarked, that's not going to work because we haven't used the name of the argument that the function help specifies. So if I run that, yeah, it throws an error. It doesn't know what to do with an x equals, so it says it's an unused argument. So I'll comment that out, and I'll run the correct one. So what's interesting here is I haven't just used the normal connections. I have just looked at the connections object, which is a locally stored object, and adjust just the first part of it, which means just the first server, using the square brackets as you would usually in R. So just looking at one table for now. So what does SCQ mean? So we need to go back to the metadata on the Opal portal for that. Oh, is that? I may not have put this in the right place. Dimitri, can you think of where this would be normally?
What are you looking now to find?
So for the key for these categories, because I know I created them in the dictionary, but I just don't know where they'd be stored. But yeah, this is just due to my setting up for the data.
Have you logged in as an administrator here or as a user?
As a user, yeah.
I'm not sure if this is, if you cannot see that because you are a user.
Yeah, I may have hidden it behind something, but hopefully you should be able to see what the SCQ actually means on a real life server. But anyway, it means where you embark. So S for Southampton, C for Cherbourg, and Q for Queenstown in Ireland. So we can see that 72% boarded at Southampton, 18% at Cherbourg, and 10% at Queenstown. And then a very small number of NAs in this data set, in this column even. And then below the proportions is the counts. So that's the raw numbers on this server, so 319, 81, and 43. So the reason that we are able to view this kind of information is because this is just an aggregated number. It's kind of information about the subjects of the study overall, but it's not revealing any particular information that can be narrowed down to an individual person. Whereas if you had, say, 2 or 3 people boarding at Queenstown, depending on the server manager's settings, it may cause a disclosure error and you wouldn't be allowed to view the table to see that there were just 2 at Queenstown, because then you could use some deduction from that to say, I know one of the people who boarded at Queenstown, and that kind of deductive disclosure. So there are disclosure checks built into this kind of function as well, even though it might not be apparent how. And then it presents the data in a little slightly different way. So table going across and counts going across. So if we hide that, what about a two-way table, two-way contingency table? So we're going to run that, and this is looking at the number who survived in comparison to their ticket class, so first class, second class, third class, etc. Oh, just seen hand raised. Do you want to ask that?
Oh yes, sorry, just a little question regarding the not available, the fact that if you have a very low number, it could be not shown to you because of concern. So in the case of the not available, there is only one here. Why is there? So
are you saying why is there the one missing value shown?
What would have been there if it was not permitted to see?
Oh, in case of this, yeah. Dimitri, could you answer that?
Yeah, basically, we have these filters in Datashield, and when you generate these opal servers, those filters are set up by their default values. And for the tables, then the minimum cell that we allow is greater than 3. So if you have any cell with counts less than 3, you don't observe anything from this table. But these thresholds, these values, can be changed by the data managers. So in some cases, for example, if you want to analyze rare diseases, you might decide to have this value equal to 1 or 0 and allow the users to see any table. So it's up to the studies to make these agreements. But initially, by default, is 3.
Okay, so you said table, not value. So in case, for example, in this example here, if you were not allowing the default less than 3, you would see, you wouldn't see completely the table, or just the line with the.
You will not see completely the table, and the reason is that even if only one cell has less than 3 counts, if you see the other cells and you know the length of the variable, you can calculate how many observations you have in this category.
Oh, okay, perfect. And thank you. The last question.
What I want to say.
Oh, sorry.
Yeah. Sorry, I want to add something, because in some cases, if you don't want to change these values, these thresholds, some people decide to merge some categories together. So, for example, if you have 3 observations in Q here, you might decide to merge Q with C if it makes sense for your analysis, for example. And in that case, you can see the table. Yeah, this is a second option that you can do.
Oh, okay, perfect. And NA was a given value in the table, just referring, because I thought that was the completeness set, so the one with all complete value. So
Oh, no, I didn't continue using that one with just
Okay,
values because it was too small.
Oh, okay,
Yeah, I
great.
should have made that clear. Thank you.
Thank you.
Can you do one? Yeah, can you do one table with the complete cases of the same variable? I think because we have very few observations, we cannot see the table. But can you try instead of having the complete?
Yeah, so I need to use the object D underscore.
Yeah.
So back to
And have also dollar and parked. We want to see the table for the same variable.
oh yeah.
Yeah.
Okay, yeah.
Yeah, as you can see, you have this message and you cannot see the table. But you can change this filter. I'm not sure if you go to the Opal interface as a user, can you see these thresholds under administrator? And then, okay, you cannot see because these values are changed by the data manager.
Yeah.
Okay.
Thank you.
Okay. So returning to two-way contingency tables. So we're going to look at survived against passenger class. So run this earlier. And so you get, for example, 0 is did not survive, 1 is survived, and then first class 33% of first class. No, sorry, that's the wrong way of reading it, isn't it? So 33% of those who survived are first class, 26% of those who survived are second class, and 41% of those who survived are third class. But then it does the other way. I thought it did. Oh no, this is, so you get the row props and the column proportions. And then you can scroll down to the counts. So that's the raw numbers that you're actually getting these results from. Also, you see that these are kind of the same structure, but you have, first of all, the first server, then the second server, and then the combined servers of all the results. So all the numbers in this table are nice and high, well above the disclosure threshold values. I've also written a note here, if you want to, you can investigate the help function for the argument where you can use the chi-square test argument. Were there any more questions before I continue on? Okay, if it's just text questions, I will keep going. So let's look at some other descriptive statistics. So just remembering what we've got available. So the survived binary marker, passenger class, name, sex, age, siblings and spouses, parents and children, tickets. Right, so probably the best one, the best numerical variable to have a look at for a mean is the age. So we're going to run ds mean x equals age. We're not going to specify the connections object here because we're just assuming it's going to look at the whole data frame. So here we get a table printout of the results of the first server and the second server. So 28.6 on 30.7. So the subjects of the study on the second server are a little bit older. But what if you wanted to have those details combined? So there's this type equals split argument, which is the default, but instead we might want to do type equals combined instead. Type equals, and then remember to put combine inside the quotation marks because it needs to be fed through the server. So that shows us that the mean age of all of the passengers in our data set is about 30. Actually, also this table shows you how many missing values there were in this particular column and the number of valid, well, the number that weren't missing that has been calculated. Well, that we used to calculate, sorry. There's another alternative function, quantile mean. It prints out the mean as well as the quantiles. So we'll run that for age. So this has only got one table of results. So if we investigate ds.quantile mean, why is that happening? I run the help function, and there we go. Type equals combine is the default argument of this function. So if we wanted to have the quantiles for each of the separate servers, we'd need to use this type equals split to modify that argument. So I'll run that line, and here we can see on server 1 and on server 2, it's slightly higher like for like on server 2, slightly higher age. What else can be done? Well, we could do histograms. So there are four graphical functions available currently on Datashield. So the first of which we'll look at is histogram. So we're going to have a histogram of the age of passengers using the standard d$age in quotations. We're going to combine them, so we're just looking at all of the passengers in our combined data sets. I've run the whole chunk, so there will also be a histogram of the split. So first of all, here's our combined histogram. So it's called histogram of the pooled data. So that's interesting. Not so many children, but otherwise quite a nice distribution of people, the mode of which is young people in their 20s. And then looking at the two different servers separately, you can't see much difference here. So the quantile mean was a more insightful function to look at that. So what other graphs are there? Well, if we went back to our list of functions, we can scroll and see. So we just looked at histogram, but there's also density grids and heat map plots and contour plots. And lastly, there are scatter plots, which we're going to look at now. Back to our session. So have a look at the help function of scatter plots first of all. So we're going to have to use X and Y to look at this. So we're going to have our X variable being age and our Y variable being fare. So that's passenger fare. And there's an error. So what have we done here? So here, for some reason, it hasn't used the right data sources. So if we specify that one, and say data sources connections, here we actually have a scatter plot. Unfortunately, it's not telling us very much because I realized that the Titanic dataset that I got from Kaggle hasn't really got that many continuous variables to plot, but I'm sure on whichever server you connect to, there will be a lot more options to plot. So you might think that each of these points is very disclosive, and if it was just directly showing those data that you'd be correct, but actually this function has been prepared so that each point is actually a randomized approximation of another data point. So it gives the general shape and trend of a distribution without being able to track down and track across and come up with an actual revealing data point. There's more details on how that is achieved using k nearest neighbors or probabilistic methods in the function help if you're interested. And in case you had the question, yes, ggplot is available, but we're not going to show that this time, just for time considerations. We are hoping to, well, if you're interested in this, we did cover it in the Athlete Beginners Workshop in January this year, which is on YouTube. And maybe there will be a session on this later this year, but we'll see. So that's a brief look at what there is. Obviously, from the list of all functions, there's a whole lot more that you can use, but that is up to you to explore. And it just remains for us to log out. But before you log out, you might actually have done a whole load of coding and have created hundreds of objects that are really finely tuned, and you really don't want to lose them, which you actually will do if you just directly log out. It will delete the session. So what you can do instead is use the workspace save command here. So datashield.workspace save. Tell it what the connection was, so that connection object again, and then the key argument here is this ws equal. So here you name what you name the workspace that you wanted to connect to. Well, you name the workspace that you want to save and connect to in the future, and then you log out. So we will run this. So those are the two arguments in order, and then we'll log out. And then say you want to the next day come back and get onto those workspaces again, you can run this login, but instead of just doing the standard thing that we saw above, you add this restore argument, restore equals, and then quote the name that you saved it as. So here it's 2021, 9th of June, Titanic demonstration. And we'll run ds list, and hopefully it should be there. Yes, so even though we logged out and it normally would have deleted everything, we can see that it has found the object d_complete cases that we created earlier. So that's all for now, and now we have 20 minutes of questions. So thanks for watching. Oh, I'll start putting these links in the chat in case you want to watch for yourselves, in case you want to have a go for yourselves.
Yeah, Alex, there is a question on how we can create a project within the Opal interface. Can you find the page that we have in our wiki for that?
I've put a link
Okay.
in the chat. I don't know if it's the right one. You can double check.
is for testing. I think this is for testing, is much complicated. And
I'm just looking at the error message in histograms. Drop down. Oh, so this invalid cells warning symbol here, Dimitri, do you know what that means?
yeah, basically, what we need to say here is that all the analysis in Datashield is run on the real data. So if you apply regression, descriptive statistics, anything that you do, you get results back to your computer based on real data. The only difference is the graphical functions. And for the graphical functions, we don't display the real data, but we apply some type of anonymization. For scatter plot, for example, one method is the probabilistic. So we add some random noise to the real values, and we show to the analyst the scatter plot of the anonymized values. But if you see the scatter plot, we make sure that the association between two continuous variables is the same as the association in real data. The correlation is the same. So all the statistical properties are preserved. So for histograms, we have one extra method, which is the default, and is the same as the method that we have in tables. So in table, if you have a cell with less than 3 observations, you don't observe the whole table. In histogram, when we create these bars and calculate how many observations we have in each bar, if there is any bar with less than 3 observations, this bar is not displayed, but we don't know where this bar, it should be at the end if we see this histogram, or at the beginning, but we don't know the exact values, because also a bar in histogram has a range. So in that case, you cannot identify exactly the values, but we get this message that there is only in study 2, there is one invalid cell, which means that we missed one bar. But this doesn't make any changes in our distribution. We can make conclusions without seeing that. Yeah, that's this warning message. Any other questions?
So I've just put the link to this script that I've been showing you today in the chat, so you can click that and download it yourself and load it into your version of RStudio. You will be able to log in to the Opal server as DS user and password. I think that's allowed. Multiple ones of you can do that at once. The one thing to note about this server is that even if you save objects like I showed you at the end there, they will be deleted overnight, because this is just a training server. Whereas if you were on a real life deployed server, you would get to save your workspaces and they would be saved overnight. Just while you're thinking of any other questions, it would be lovely to hear your feedback of how you think this this session went. So the way we'd prefer you to do it, if possible, would be to sign up to our forums. So you can just tell us what you think we did well and what you think we could do better. But then you're already signed up to our forums and you'll be able to post any questions you have about actually using Datashield.
Sergio has a question.
Yes, thank you. Just a last thing regarding the like in your animation server in different places, so different servers. So everything you've done with the two table in the same server, you can actually do if the table were in different places, I suppose.
Yeah.
So exactly the same.
Yeah. And basically, for simplicity, for this tutorial, we put two datasets in the same server. But all the commands are the same, even if you have these two datasets in two different servers.
Okay, perfect. Thank you.
The only difference is when you log in, you have to specify different URLs. For
Yeah. In the first connection thing. Okay, thank you.
Any other questions?
If you'd like to have a look at any of these explanations again, we will be trying to get it uploaded to our YouTube as soon as possible. It's just we'll have to wait for the Zoom to process the recording. But yeah, this will be available, and you can get to that on our Datashield website, datashield.org. From Milena, seems very difficult to use the system if you're dealing with very rare outcomes. Is this correct?
Alex, can you log into the Opal interface as an administrator?
Yeah. 1 second, sorry.
Yeah, basically, if you want to deal with rare outcomes, and if you use the default thresholds, most of the functions you will get, most of the functions will be blocked due to disclosure controls. But I will show you here, there are some consortia, for example, that are dealing with rare diseases or any rare outcome, and they agree in between them to change those filters. And in some other cases, each cohort can have its own set of filters. We don't need to have the same filters across all cohorts. Alex, can you click Datashield?
Yeah.
So this can be changed by the data manager who owns the data. And these filters are what we have under options here. We have, I think, 8 filters. So the one, for example, the one that we have for the table is the default and filter tab. So as you can see here, the number is 3, but you can just say remove, and you will see a window, and you can specify a different number there. You can put 1, for example. And we have also some other filters for other functions. For example, one filter is for GLM, and this 0.33 means that you have one dataset with 100 participants, and you have a model with 100 parameters. If you run this model, then the estimated coefficients can be used to infer the real data. So what we have here as a filter, as a threshold, is this 0.33, which means that you are allowed to have a model with up to 33% parameters, which means that if you have 100 participants, you can have a model with 33 variables, which is quite big model anyway. But we have those filters, and this can be changed depending on what you want to analyze by the data manager. The user cannot change those filters. Yeah. The other thing that I want to say is in the link that Alex showed you with a list of all the functions that we have, those functions are all the functions that we include in the base package of Datashield. At the moment, we as a Datashield team and some of our collaborators are developing some other packages For example, we have a package which is called DSExposome, which is for analysis of exposome data. This package includes more functions which are not listed here. And we have a number of packages which are at the moment are developed by external developers. So in the nearest future, we need to add in this list. We need to create a similar list for each package here in our wiki. So there is a question if you need to install the VMs. For us, basically, you can install the VMs if you want to run a training session that we have in our wiki. But to avoid installing the VMs, we have this Opal server that Alex showed you, and you can have access to this Opal server using the username and password as a user. And this Opal server is live at any time, so you don't need to install VMs. But of course, if you want to create your own project and play with different fake data, you can install virtual machines. In a real setting scenario, if you are a user, everything is much simpler because you don't need to worry about how the data are uploaded, how the server-side packages are installed, but you have only to get credentials to access the studies and then run Datashield commands. So as a user, the whole process is much easier.
Yeah, I will be editing the wiki soon to make it obvious that using the demo server is the standard way of doing it, because it is far easier. In previous tutorials like this, we spent up to 20 minutes getting the virtual machines set up and running. So that is a big time sink that you can avoid by logging into the Opal servers that are already existing.
I think we don't have any other questions on the chat. I hope that I didn't miss anything. So with thanks everyone. Do you want Alex to say where they can send us any questions? Yeah, I think you put everything on.
Yeah, so yeah, to get further help, we invite you to join our forum. So that's I'll show you. So you go to the homepage of the website and then support and forum. That gives you the link. And it's datashield.discourse.group. I have created a beginner support feedback thread. So beginner support was this green link here. And then if you can reply to this thread saying what you liked and what you would like to see in addition to what you saw today, if you post a new topic about any other questions you have, this is the ideal place to receive feedback from the whole community. You are, of course, welcome to email Datashield at newcastle.ac.uk, our email. That's available from the website Get in Touch email. And yeah, there are also regular drop-in sessions That's on the home page. Drop-in sessions. Yeah, if you'd like to come and say hi and discuss your script and what problems you might be having with it. Thank you.
Thank you. Bye.
Thank you.
Bye.
Bye, thanks.
Bye.
Thank you. Bye.
Thank you.